Alright class, the main concept we're going to be talking about today is the idea of sound and sound waves. We already know what a sound is, but I'll explain it to you anyway. Sound is basically the energy that we use to hear anything. So for example, our speaking, that produces a sound that we all can hear, and then get information from that. Before I get started in this lesson, I wanted to ask these two questions written in red. Can sound travel through space? This is going to be the first question that I ask because this is a very common thing that I see from students, and I want to hear everyone's opinions on this. I'll give everyone about 5 seconds, but since there's no one here, I cannot hear any physical yes or no answer, so I'll have to answer it myself. Okay, 5, 4, 3, 2, and 1. Okay. The question for can sound travel through space, the answer is no, and that is because space is a vacuum, and a vacuum often lacks matter. The reason why this is important is because this impacts the way the sound travels from. Because if it has no matter, that means no sound can be produced. The next question is can matter impact how sound is traveling? I'll give everyone about 5 seconds. 3, 2, and 1. Okay, the answer for this question is if matter can impact how sound is traveling, the answer is going to be no in this. Actually, it is going to be yeah. Sorry about that. I had a little tongue slip there. It does impact it because it often changes how everything is echoing. It changes how everything is reflecting off sound-wise. And more importantly, it can also change the way that sound is traveling in the way that we receive it. So if I was going to speak through this empty cup, for example, this would change how the way I'm speaking sounds and the sound traveling through this room. I'm just going to provide a demonstration right here, right now. Right now, everything sounds normal with the way that I speak. However, once I start speaking through this glass, it also produces a different sound because it is bouncing from a different matter. Matter, a different form of matter. That is the idea for it. And I wanted to get these parts out of the way because these are often two common misconceptions that I hear because it does impact the way that sound is traveling from, because different states of matter have different priorities in how sound can travel through, which we'll cover through in the lesson later. Okay, so the next question is going to be, what is sound waves? Sound waves is the energy that helps create sound. Sound waves are basically the forms of vibrating matter. So once I type this, that is technically a form of vibrating matter because this interaction is causing a vibration that will help make the sound that we hear because of sound waves. That little tap created a little sound wave that traveled through this room, and that was what was able to help us hear the sound of the tap. Okay, so if they're from vibrations, that leads into what is the term going to be called for the amount of vibrations that are going on? So if I repeatedly tap this marker up on the board, like what is the frequency of this? The frequency is basically just going to be the number of vibrations that a sound wave is emitting off per second, or the forms of matter is given off per second, because let's say that there was like 5 taps a second, which created like about 10 vibrations for each tap. That would be about like 50 vibrations for 5 taps. Like that is a form of frequency that is going on. It's a terrible example. I do not have the exact I don't have an exact formula with me to work with, but the main idea of frequency is that it is the number of vibrations from vibrating matter that is helping create the sound. It's just the number of vibrations basically. Okay, so if we know the number of vibrations and we know what frequency is, what does frequency exactly impact? And that is where the term pitch comes in at. Pitch is more or less the frequency of the sound wave, and it's basically the impact of the frequency of the sound wave, and it creates a high pitch or a low pitch. So if I raise the pitch of my voice, it would often sound a lot higher. I cannot exactly do that right now because my voice is kind of messed up from allergies. So that's why I'm keeping a lower pitch in mind. I'm trying to keep a lower frequency in mind so that I am able to create a lower pitch, which helps keep my voice stable. So now that we know what each of these are, what does pitch and frequency have to do with anything? And that is where the term amplitude or volume comes in. Whoops, sorry about that. Amplitude or volume is more or less the power of the sound wave, or basically how loud or how quiet the sound is. So if I spoke really loud like this, you could often hear this because I am often producing enough power for it to be heard across a small room. However, if I do something like oddly tap my fingernail across this board, it would be hard to hear because it is a lower frequency or a lower volume at mind. It is a lower amplitude, thus a lower volume. However, if I do, for example, knock this cup against the board, like that is often a louder amplitude or a louder volume. Okay, so the main question now then becomes, how does it travel across this room instead of just being located at this specific object? It's where you only need to be directly near it in order to hear it. That is because of the concept of echo. Echo is more or less sound waves bouncing off and reflecting on surfaces. Surfaces of matter. Okay, imagine this half square as a corner of a wall. Imagine this stick drawing as just a person about to randomly speak. And imagine these little squiggles being the sound that's produced from him talking. They will then echo into other parts of the room. And that is where sound is starting to then travel from. It will bounce off the surfaces of the wall, if it's in a corner, and then reflect off everywhere. Sound is going to be traveling through in different directions. So for example, if a person is speaking to the right, the sound will often travel to the right. And then vice versa with the left if they're speaking from the left. And that is why whenever you're hearing me more, you'll likely hear me more from the right side because I'm speaking and pointing at this direction rather than this direction. This is a good example of how echo can impact things because instead of needing to be directly around the proximity of the speaker, echo can help travel sound through until it reaches this person's ears or whatever is the projected target. Okay, so now the question then becomes, how does sound travel? And that is through a medium. A medium is more or less going back to the states of matter. Does anyone want to take a second to point out the 3 states of matter? Since no one is in here, I'll have to run it myself. But it's basically a solid, I'll put an S for it, a liquid, and a gas. A solid, liquid, and gas. These are the 3 states of matter, and they all impact the way that sound can travel through. Despite the idea of gases potentially sounding like the idea for where sound can travel the fastest and most powerful through, because of where the particles for the state of matter are often very dispersed at times, sound is often not going to be created much because there's a little vibration occurring from that. And that could be the same case for a liquid too, where it's a little bit closer, but it is not like jam-packed together. Meanwhile, as for a solid, because of where the matter is often very bundled up here, solids are often traveling the fastest. So from greatest to least amount of travel, sound is often going to be traveling the most, while gas is going to be traveling the least because solids are often very closely packed together matter that is going to be causing a lot of vibrations, and that will create the sounds at mind. So, for example, this marker, whenever I tap on it, to this board, it is a solid interacting with another solid, creating its own vibrations that lead into the sound that's being created. If I wave this marker around, while there can technically be a sound, it is it is so quiet that the human ear cannot hear it. However, if I say, for example, like throw this into a thing of water, it is a solid interacting with a liquid, so sound will be made, but it won't be as loud as just a solid hitting a solid. Are there any questions for this class? Since there's no one here, people could just email me or talk to me after class or through Google Classroom. And speaking of Google Classroom, I'll leave a video of this for students to reference, and I'll be leaving a visual aid as well as the assignment, which is to just define these terms or think of examples that you guys can apply each of these towards. So say for example, like a pitch, you're going to be thinking of like a high-pitched voice. For frequency, you're going to be thinking of like a lawnmower having a certain frequency whenever your dad starts it up. A medium, you guys could just think of it as just like any random state of matter. So like let's say you're wanting to pour water into a glass. That is an example of sound traveling through medium because it is matter interacting with other matter and creating a sound. Amplitude, you can just think of volume, so imagine like a concert. And then echo is just imagine just going to a very quiet and large room and just screaming really loudly. That is a good example of that. You guys can just think of your own examples. I'll be providing them through Google Classroom. If needed as well, I can email this video to the caretakers of the students as well, just in case Google Classroom is not working. But if there's no questions left for today, thanks for listening in on this. But to sum up the main points, sound is the energy that we all use to hear from. Sound waves help create that sound, and these sound waves can create a lot of different terminology that all creates its own form of sound. Pitch helps create a different sound. Frequency is the amount that helps create the pitch. Amplitude is the volume or the power of the sound wave. The echo is what helps bounce around the surfaces from mediums that eventually reaches to our ears. Since there is nothing left for us to talk about, thank you all for listening in, and I hope everyone has a wonderful day.